Ho ho, welcome! It's time for an end of the year science stream where I, Caprolux, will be sharing the latest science news with you. I made this little placeholder picture because I figured it'd be nice to have a little image on the screen before I actually start. So this'll, or maybe I'll keep it because it's kind of cute with how relatively badly it's drawn. But yeah, we got a lot to cover today. So we'll have some music for the festive spirit, and we'll jump right into it. So this first one I'm gonna go over. Talk about how artificial intelligence can predict events in people's lives. And again, most of these stories I have not read at all, so I'm gonna be learning with you, and hopefully be able to explain most of the stuff along the way. What else is I gonna say? But also, the majority of these articles is probably going to be more biology in nature, as, oops, sorry, that's kind of just my wheelhouse, and that's kind of what I come across more often. Hello, Sleepy, yes. I am curious about this. This came from a technical university of Denmark, so I am curious what they, article title aside, what they're saying by can predict events in people's lives. Because sure, there's some predictable events like we all got a schedule. We all wake up, do this and that, go to work, whatever. But I'm curious if it's going to get into something more like, oh, this will... I doubt it'll be able to predict when you die, because we're very, very bad at predicting that. Very terrible at predicting that, in fact. But I wonder if it's going to be something like, oh, you're going to be sick this, around this time. Let's see. Artificial intelligence developed a model written language. And a lot of these don't really have pictures, so oops, sorry, it will be walls of text. But you can just listen to the narration with my voice. See, written language can be utilized to predict events in people's lives. Research project from DTU, University of Copenhagen, ITU, and Northeastern University in the US shows that if you use large amounts of data about people's lives and train so-called transformer models, which, like ChatGPT, use to process language, they can systematically organize the data and predict what will happen in a person's life and even estimate the time of death. I don't know about that. Listen, I'm not saying it's impossible, but I don't think it'll give a great estimation, personally. But who knows? Maybe with the machines taking over, maybe they are good at being able to predict time of death. So let's see. Blah, blah. Okay. Let's get into it. Predictions from Life2Vec are answers to general questions such as death within 4 years. When the researchers analyze the models, also you'd have to test this, right? Be like, hey, take this group of, say, 50 people. How many people are going to die within the next 4 years? And then it's like, oh, 10 of them. And it's like, all right, we're going to have to check in our 4 years, see how many of you died. Let's see. Yeah, I think that's another thing. Is if someone has a chronic illness or something, it would be like, oh, you are more likely to die sooner. It's like, oh, gee, thanks. Yeah. So let me see if I can get into the details of how they set this up. So let's see. Results are consistent with existing findings within social sciences. For example, all things being equal, individuals in a leadership position or with a high income are more likely to survive. Okay, yeah. There you go, right there. While being male, skilled, or having a mental diagnosis associated with a higher risk of dying. So yeah. Life2Vec encodes the data in a large system. Also, it is kind of one of those things of, where is it? Yeah, I think with large amounts of data about anything, you can you do become more able to predict stuff. It's more like, how much of that data do we want to really feed into this thing? So sure, Life2Vec codes then data with a large system of vectors, mathematical structure that organizes different data. Model decides where to place data on the time of birth, schooling, education, salary, housing, and health. So what I'm kind of getting from this so far is we got nothing new from this. But with the new popularity of AI, we want to be like, AI can predict it. What's exciting is to consider human life as a long sequence of events, similar to how a sentence in a language consists of a series of words. This is usually a type of task in which transformer models and AI are used. For our experiments, we use them to analyze what we call life sequences, i.e. events that have happened in human life, raising ethical questions. Researchers behind the article point out the ethical questions surround Life2Vec models, such as protecting sensitive data, privacy, and the role of bias in data. Bingo. These challenges may be understood more deeply before the model, or must be understood more deeply before the model can be used. These challenges of going around ethics. For example, to assess an individual's risk of contracting a disease to other preventable life events. Model opens up important positive and negative perspectives to discuss and address politically. Similar technologies for predicting life events and human behavior are already used today inside tech companies that, for example, track our behavior on social networks, profile us extremely accurately, and use these profiles to predict our behavior and influence us. Marketing, great. The discussion needs to be part of the democratic conversation so that we can consider where technology is taking us and whether this is a development we want, says Soon. You are so right. According to the researchers, the next step would be to incorporate other types of information, such as text and images or information about our social connections. This use of data opens up a whole new interaction between social and health sciences. I don't know, so far I'm not convinced. You don't really have me on like anything super new being here other than talking, hey, you know, we need people's data more so we can predict every event in their lives. So let's learn about the research project. Using sequences of life events to predict human lives based on labor market data and data from the National Patient Registry and Statistics Denmark. Dataset includes all 6 million Danes and contains information on incomes, damn, all of them? Income, salary, stipend, job type, industry, social benefits, etc. Health dataset includes records of visits to healthcare professionals or hospitals, diagnosis, patient type, and degree of urgency. Curious about how they quantify that. Dataset spans from 2008-2020. Ooh. But in several analyses, researchers focused on the 2008-2016 period and an age-restricted subset of individuals. So I'm curious if this has been in the works for like a long while, just with like, you know, machine learning, which is what most AI is. Transformer model is an AI deep learning data architecture used to learn about language and other tasks. Models can be trained to understand and generate language. Transformer model is designed to be faster and more efficient than previous models. It's often used to train large language models on large data sets. Okay, neural networks. Okay, let's see. Can we get? Let's get into the nitty gritty of this, because I'm a little curious. It got me a tiny bit curious. I have to pay for it. Well, unfortunately that's not happening, so I think we'll move on and we'll just say it's one of those could have told you that sort of works. Because so far it doesn't seem like it's really taken off the ground at all. But this one, apes remember friends they haven't seen for decades. I figured this sounds like a fun little, nice friendship-filled thing of apes remembering people. Let's see, longest lasting non-human social memories ever documented. It's from Johns Hopkins University. Let's see, apes recognize foes or group mates they haven't seen for more than 25 years and respond even more enthusiastically to pictures of their friends a new study finds. The work, which demonstrates the longest-lasting social memory ever documented outside of humans, and underscores how human culture evolved from the common ancestors we share with apes, our closest relatives. So let's see. The work, which demonstrates the longest-lasting social memory, There are apes. Chimpanzees and bonobos recognize individuals even though they haven't seen them for multiple decades, said senior author Christopher Rupinai, an assistant professor at Johns Hopkins University who studies animal cognition. And then there's this small but significant pattern of greater attention toward individuals with whom they had more positive relationships. This suggests that this is more than just familiarity, that they're keeping track of aspects of the quality of the social relationships. Hell yeah. Love that apes actually do make good connections and stuff. Adds lead author Laura Lewis, a biological anthropologist and comparative psychologist at the University of California, Berkeley. We tend to think about great apes as quite different from ourselves. We have really seen these animals as possessing cognitive mechanisms that are very similar to our own, including memory. And I think that's what's so exciting about this study. We really are all just ape. The research team was inspired to pursue the question of how long apes remember their peers because of their own experiences working with apes. It seems that the animals recognize them when they'd visit, even if they'd been away for a long while. You have the impression that they're responding like they recognize you and that to them, you're really different from the average zoo guest. They're excited to see you again, so our goal with this study was to ask empirically, if that's the case, do they really have a robust, lasting memory for familiar social partners? Now, the good thing, the best thing about this is that if they have good relationships, that also implies they have really bad relationships. So if you're at a zoo, or if there's someone at a zoo and they're just like a real piece of shit to the monkeys or to the apes, then they'll know. They'll be like, oh, it's this asshole. That one that was throwing peanuts at me years ago? It's that dickhead. Yeah, a very telltale monkey will remember. Let's see, teamwork with chimpanzees and bonobos at Edinburgh Zoo in Scotland, Plankendale Zoo in Belgium, and Kumamoto Sanctuary in Japan. Researchers collected photographs of apes that had either left the zoos or died. Damn. Individuals just make them sad. Individuals that participants hadn't seen for at least 9 months, and in some cases for as long as 26 years. The researchers also... Sorry, I got thrown off by the vocals. Okay, hold on. Actually, I might just skip this one. It's better with the instrumental. Also, oh god, who is that? There was that one lady, that she thought she really had a connection with like the gorillas in the zoo or whatever, and she just kept smiling at the gorilla. But the thing is, if you stare a gorilla in the eyes and or smile at it, you are actually challenging them. And this woman was so certain. She was like, no, we have such a great connection. Like, we're so, you know, like, ape to human. Like, we've really got it. And this gorilla actually at some point broke out, and I'm pretty sure it beat the shit out of her. And she was still like, oh man, best pals, me and that gorilla. And I do wonder if that gorilla is always just like, I'm tired of this bitch that is coming up to me and challenging me every single day. Let's see, where was I? Researchers collect photographs, researchers also collected information about the relationships each participant had with former group mates, if there had been positive or negative interactions between them. Ooh, so they are exploring it. Team invited apes to participate in the experiment by offering them juice, and while they sipped it, the apes were shown 2 side-by-side photographs of apes they'd once known and total strangers. I do like that most ape studies that I've seen does involve food motivation. It's very good. Let's see. Using a non-invasive eye-tracking device, the team measured where the apes looked and for how long, speculating they'd look longer at apes they recognized. The apes looked significantly longer at former group mates no matter how long they'd been apart. And they looked longer still at their former friends, those they had more positive interactions with. In the most extreme case during the experiment, Bonobo Louise had not seen her sister Loretta nor nephew Aaron for more than 26 years at the time of testing. Damn. She showed a strikingly robust-looking bias towards both of them over 8 trials. The results suggest great ape... I wish they gave number. I guess like a quantifiable, like, oh, stared at for like 20 minutes or something. The results suggest great ape social memory could last beyond 26 years. Majority of their 40 to 60 year average lifespan, and could be comparable to that of humans, which begins to decline after 15 years but can persist as long as 48 years after separation. Such long-lasting social memory in both humans and our closest relatives suggests that this kind of memory was likely already present billions of years ago in our common evolutionary ancestors. This memory likely forged the foundation for the evolution of human culture, enabled the emergence of uniquely human forms of interactions such as intergroup trade, where relationships are maintained over many years of separation, the author said. I do like evolutionary studies. I was just like, oh yeah, this is kind of why we act the way we do. Good day, Riven. Good day. You're just in time. We're talking about how apes have good lasting social memory and how they remember their friends. The idea that apes remember information about the quality of their relationships years beyond any potential functionality is another novel and human-like finding of the work. This pattern of social relationships shaping long-term memory in chimpanzees and bonobos is similar to what we see in humans. Our own social relationships also seem to shape our long-term memory of individuals, Lewis said. And it's basically, bottom line is it seems like we are more ape than we think we are. The work also raises the questions of whether the apes are missing individuals they're no longer with, especially their friends and family. The idea that I like that song was just that 30-second thing. The idea that they do remember others and therefore they may miss these individuals is really a powerful cognitive mechanism, something that's been thought of as uniquely human, Lewis said. Our study doesn't determine they are doing this, but it raises questions about the possibility that they may have the ability to do so. The team hopes the findings deepen people's understanding of the great apes, all of which are endangered species, while shedding new light on how deeply it could be affected when poaching and deforestation separate them from their groupmates. I was curious about this part of the study. Louise, who hasn't seen her sister or nephew for 26 years, I'm like, oh, like, you know, did they die? Were they separated and moved to different zoos? Like, what's the story there? Let's see. This work clearly shows how fundamental and long-lasting these relationships are. Disruption to those relationships is likely very damaging. He would next like to explore whether these long-lasting social memories are special to great apes or something experienced by other primates. He would also like to test how rich the memories of apes are if, for instance, they possess lasting memories for experiences as well as individuals. Huh. Isn't that nice? The ape brain is not as empty as we would think. Ah, yes, this one. This one's a bit more festive. Coevolution helps Santa's reindeer feast after flight. So I'm curious what this came from Dartmouth. I'm curious about what this gets into with Santa's reindeer, or if it's just something about reindeer in general. So let's see. Reindeer vision may have evolved to spot favorite food in the snowy dark winter. Okay, so maybe that's what it's about. When Santa's exhausted reindeer finally set down their sleigh in the deep snow of the North Pole early Christmas morning, it's not Rudolph's radiant red nose that will help them find sustenance in the barren landscape. Instead, researchers from Dartmouth and University of St. Andrews in Scotland report that the eyes of Rudolph and his reindeer brethren... Please, just tell me they actually phrased it this way. Oh my god. Reindeer and the quest for Scottish and enlightenment. This is so good. Oh, and they have the full article here, thank god. I have to like delve into this a little bit. Let me see if I can... Ugh. Here, let me try this so it's not cut off. Pivot. No, that won't work. Okay, let me just go through this for a second. It'll be real quick. I just want to see what other like fun little, you know, like, oh, Santa and Rudolph and stuff they throw in. Let's see. Yeah, I think it'll make sense that they do have some sort of evolutionary benefit to searching for food. And, you know, depending on where they live, in a place that might not be very easy to see that food. But I just... Scottish enlightenment is very good. Let's see, blah, blah, blah. Uh-huh. Okay, they actually don't get into it as much. They're not as cheeky with it. But that's okay. Anyways. Where were we? So let's see. Science help explain the long-standing scientific mystery as to why reindeer can see light in the ultraviolet spectrum. Oh, that I actually didn't know. And add intrigue to the smiling airborne ungulates popularized in the classic story by 1926 Dartmouth graduate Robert L. May. Is it oh, hold on. Classic story? 1926 by May? Let's see. Or is this... Never mind. Reindeer are so cool, but many people think that about them only at Christmas, Nathaniel Dominy, first author of the site, and Charles Hanson, professor of anthropology at Dartmouth, said. Now is a good time to alert people to their extraordinary visual system. I wonder if they also systematically were just like, hey, we'll put this study out during near Christmas season so that people actually like look at it and pay attention to it. Reindeer subsist primarily on reindeer moss, or Cladonia ringiferina, which isn't a moss, but actually a species of algae fungus fusion known as lichen C. ringiferina, forms thick, crunchy carpets across northern latitudes, and is so integral to the survival of reindeer. Even its formal name stems from the scientific term for reindeer, ringifer. Researchers worked in the Cairngorms Mountain in the Scottish Highlands, which hosts Britain's only reindeer herd, reintroduced from Scandinavia after being hunted to extinction locally. More than 1,500 species of lichen. Huh. Despite these options, reindeer in the Cairngorms rely on C. ringiferina during the winter. You know, I guess I never really thought about what reindeer really eat in general, but I guess lichen would be widespread enough to be good for sustenance of reindeer. Peculiar trait of reindeer is their reliance on this one type of lichen, Dominy says. It's unusual for an animal to subsist so heavily on lichens, let alone such a large mammal. And, yeah. I'm trying to remember. There's a species I found out about recently, and it was like it was almost a species of like how did you evolve to like survive this long? It's like you live in a shitty place and you don't really have any survival mechanisms in general. It was just like how are you here? But I do think evolution is very interesting in that way of just being like the tiny, teeny little mutations of like, oh yeah, they like these animals grew fur, these animals, you know, like these birds were able to get this specific food type or whatever, you know, had the beaks for it. It's very interesting just seeing all the different ways that things came together through history instead of just life dying out at some point. Life finds a way. Yeah. And that's why, also a lot of fish, they actually, if I remember correctly, they can only see red light, I think. And so a lot of fish evolved past that for survival to where, you know, they're just like other colors or whatever, so that they can't be seen by the deep sea fish that can only see red, like very long forms of wavelength forms of light. And it's just like looking at it, it's such a wild puzzle from a scientific point of view. Let's see, to the human eye, white lichen is invisible against the snowy backdrop of an Arctic winter. I feel like many things would be relatively invisible like that, but Domini and co-authors Catherine, I like the idea as well of like, oh, this white lichen is actually straight up invisible. You can it only produces, or you can only see it through UV light. Yeah, and I don't know a whole lot about what is it? The wavelengths of light that bees can see. But that's also a very interesting aspect for how they go searching for flowers and such. Oh, this one's jammed. So let's move this over here. Be a bit more visible. If it's not. I know it. Yeah, they definitely see UV as well. But I think also they see visible wavelengths of light, or we have visible light or whatever, but it's more from our perspective, so it's weird to say that. So let's see, Dominique and co-authors Catherine Hobert and Julie Harris from St. Andrews discovered that C. ringfarina and a few other lichen species that supplement the reindeer diet absorb UV light. Spectral data from the lichen light filters calibrated to mimic reindeer vision revealed these organisms appear to reindeer as dark patches against an otherwise brilliant landscape, making them easier to locate. Okay. Getting a visual approximation of how reindeer might see the world is something other studies haven't done before, says Domini, who published a paper in 2015 on how Rudolph's red nose would have acted as an effective fog lamp in the haze of winter. Domini, thank you for looking into reindeer purely from the aspect of the Christmas reindeer. It's very good. If you can put yourself in their hooves in this white landscape, you'd want a direct route to your food, he says. Reindeer don't want to waste energy wandering around searching for food in a cold, barren environment. They can see lichens from a distance that gives them a big advantage, letting them conserve precious calories at a time when food is scarce. It does make me curious though, why... Are there other lichens then that would absorb UV light, or is it only this lichen in particular that seems to absorb it? Previous research has shown that reindeer eyes change between summer and winter, Domini says. Their tapetum, the light-enhancing membrane that gives many animals shiny eyes, transitions in winter from the golden color most animals have to a vivid blue that is thought to amplify the low light of polar winter. I mean, let me see if I can find something about that. It's kind of interesting. Let's see. Deer eyes, winter and summer. Well, I wish I could find one without, I guess, an artistic representation. Oh, here we go. Although even this, I'm not sure if it's a real picture or if it's just enhanced, but interesting. I actually didn't know that. I'm learning so much about reindeer today. So let's see. If the color of the light in the environment is primarily blue, then it makes sense for the eye to enhance the color blue to make sure a reindeer's photoreceptors are maximizing those wavelengths, Domini says. But the blue tapetum also lets up to 6% of ultraviolet light pass through to the eye's color sensors. No. Alright, hold on. Now the vocals, please. That means the reindeer see the winter world as a shade of purple, similar to how a person would see a room with a black light. UV reflecting surfaces, such as snow, shine brightly, while UV absorbing surfaces are starkly dark. I guess that would make sense. And yeah, as I got here, I was starting to think, I'm like, what about the reflection of UV light? Researchers recount how scientists have sought to answer why the eyes of an Arctic animal that is active during the day would be receptive to UV light that would be reflecting off of every snow-covered surface. Yep. The study suggests that the answer is tied to what UV light doesn't reflect from, seeing Ringiferina and other bushy lichens. It does maybe also beg the question a little bit of like, depending on how heavy the snow can get, it would just kind of cover it all up, right? And they wouldn't really know where to search, even if it was all over the place. Given the importance of lichens in the reindeer diet, researchers report it is possible that the animal's eyes are optimized to single out this food staple at the time of year it would be most difficult to find. So, while the luminescent nose of the most famous reindeer of all may light the way for Santa to see by, or as they reported earlier, wouldn't be very good at all, researchers write it is Rudolph's blue eyes that allow him to find dinner after a long Christmas season. I learned a lot about reindeer today. Alright, so next. This one, and sorry, this site, it kind of cuts off with the overlay and everything, so oops. But this is talking about vocal therapy changes vocal cords to transgender patients without need for surgery. Voice changing approach offers an inexpensive option for gender affirming care, researchers say. So basically, I think this article gets into we need to put a little bit more efforts if someone wants to change their voice into just having vocal therapy rather than like looking towards surgery as an option for it. For transgender people, transition can be a complex process. To make the way these individuals present to others match their preferred gender, they can engage in relatively small changes, such as adjusting their wardrobe, or medically intensive ones, such as hormone replacement therapy, HRT. They can even undergo surgery, as when trans women want to alter their vocal cords to create a more feminine voice. The procedure is expensive and often requires months of recovery and therapy. Maybe an easier way. A new study in the journal Voice shows that a non-invasive treatment called vocal therapy may be enough to physically alter trans women's vocal cords and change their voices, expanding treatment options for this group. The study shows that vocal therapy causes actual psychological changes in the larynx, says Angela Damasio, speech-language pathologist at the University of Cincinnati, who is not involved with the work. It's not just a feeling. Vocal therapy has long been part of the suite of treatments that help trans people transition. The method involves a range of exercises to release tension in the throat and strengthen vocal cords, which can result in changes to speaking patterns, pitch, or breathiness that help trans individuals protect their gender identity. Trans women usually seek out a higher pitch, breathier voice, as these are traits typically perceived as feminine. They also tend to pursue voice training more often than trans men do, which I... like, when I read this, I was like, you know what, that actually does make sense. I think I, do hear much more often of trans women wanting to change their voice a lot more, and it makes sense. In part because puberty permanently changes the shape of these women's larynx and deepens their voice. Charlie Hughes, otolaryngologist serving in the U.S. Navy, and colleagues were providing vocal therapy treatment to transgender patients when they noticed their trans women patients sometimes had thinner vocal cords than cisgender patients, whose gender identity matches the sex assigned to them at birth. Some of these trans women had previously undergone vocal therapy, whereas others were seeking help for other ear, nose, or throat issues. Is there something going on with when you're typing something? Hold on. Oh. Let me see. See if that's something going on there. I think I have to take care of it here. I actually forget where I see that stuff. Yeah, sorry, I don't know where that is unless here. Nope. Very annoying. Oh well. Apologies if you're trying to say something that's not getting through. Let's see. Researchers whose work wasn't funded by the military examined footage of the vocal cords of 14 trans women as they spoke. That's a small sample size, admits the study's senior author Greg Dion, laryngologist at UC. But he says you gotta start somewhere. Of this group, 2 patients had not received any prior treatment, or had only been using various forms of HRT. 1 had only undergone vocal therapy, and 7 had received both vocal therapy and HRT. The researchers measured the opening between vocal cords, known as the glottal gap, as they opened, closed, and vibrated, while the women spoke at different pitches. The glottal gap, on average, was larger in women who had undergone vocal therapy, regardless of whether or how long they had been on HRT, the scientists found. Further analysis actually, how do... I'm guessing you just have like a little camera or something going down the throat or whatever, but I wonder how you'd visualize that. Let's see. So, further analysis revealed that the lengthening of the glottal gap was linked with having received vocal therapy, not with taking HRT. The study also found that the longer someone underwent vocal therapy, the larger glottal gap became, giving them a higher pitch and breathier voice. The results suggest vocal therapy on its own can change the physical qualities of the vocal cords, even without surgical intervention, says Clark Rosen, laryngologist at the University of California, San Francisco, who wasn't involved with the work. This study shows that there's a proven objective value of voice therapy. Dionisio says she'd like future studies in this area to focus not only on physiological changes, but also on whether those changes actually aided the patient's transitions, such as by whether these women were perceived to be of their desired gender by others. Overall, the authors say they hope their work will play a role in helping trans individuals more easily and cheaply access vocal therapy. Getting voice therapy covered by insurance companies for transgender individuals is like pulling teeth sometimes, Dion says. For a number of reasons, a lot of insurance plans don't cover voice therapy, and this is a great start to saying this is why we need this approved. A constant fight against insurance to be like, hey, we need this thing, or we want this thing, or whatever. And insurance is just like, we don't really know if you do need it, though, so, Very annoying. Wait, hold on, I'm gonna try one other thing. Let's see here. This is it. Okay, but I don't see anything. Whatever. Okay, moving on. So yeah, I guess it's kind of one of those things of like, well, I guess it's not really covered by insurance, but seems like there's a little bit more. I'm also curious though, did they say they did anything with trans men also? Or was it only... Yes, I only looked at trans women, so I'm curious about how much vocal therapy helps trans men as well alone. So I feel like that's something that needs to be looked at as well. But interesting. Alright. And this is just a sort of general article talking about the biggest medical advances in 2023. New treatments include the first CRISPR gene editing therapy, which I can't believe I haven't talked about this yet, but that is very exciting. An Alzheimer's drug and RSV vaccines. Which, yeah, like, I guess being in the scientific field, obviously I kind of know a little bit more about some advances of certain things. Because I saw a lot of people being like, yeah, wow, I didn't even know, like, CRISPR had been around for this long, or, like, had been studied this much. And it was like, yeah, it's like, pretty much since we first had CRISPR, we've been studying it, working on it, but I'm like, I guess I can't blame them for not knowing, because, you know, who's really keeping an eye on it in general. But very exciting. And I feel like it does make sense that CRISPR is first being used to look at sickle cell treatment, since that is a relatively small fix for it. And I think, like most scientists, it's just a bit of like, you know, but keep an eye on, like, if there's any effects or anything that come out of using CRISPR on a wider therapy, you know, base level. Let's see, so we got the green light for CRISPR gene editing. December 8th, US FDA approved the world's first CRISPR-Cas9 gene editing therapy. It's actually the world's first. Treatment called Casgevy, sure, targets sickle cell disease by helping patients produce healthy hemoglobin. Does it talk about it? Yeah, so the reason why using CRISPR for sickle cell disease is actually caused by, I might have to actually double check this. I think it's a single base deletion. And essentially, it's gonna throw me off every time. And then basically every single time this deletion occurs and how DNA is read, it's gonna mess up the entire protein, which you know, if you haven't seen it, basically makes your blood go from normal to, you know, a bit of a sickle-shaped blood cell. And obviously, not good, not great. And so I'm guessing what they might do is put CRISPR maybe into their bone marrow, because that's where the blood cells are made. But I'm unsure about the target specifically. So let's see, because I think once the blood cell's made, you know, they can't really change it to go from abnormal back to normal. And it might also be a constant therapy. So I'm not sure, you know, how that's all gonna look, but very exciting. Hey, Ringo. Welcome. We're talking about medical advances of this year. So let's see, in people with the disease, hemoglobin is abnormal, causing red blood cells to become hard and crescent-shaped, which can block blood flow. In March, the FDA will decide whether the same therapy can be used to treat beta thalassemia, a disorder that reduces hemoglobin production. Okay, so that's actually just it about it. Oh, I guess I can go to each article if I want to. That's okay. Let's see, slowing down Alzheimer's. Ooh, right, the new Alzheimer's drug. I think we covered this, maybe. Lecanemab won full FDA approval in July. Like the drug aducanumab. God, let me tell you, constantly coming across new words in scientific studies and not knowing the pronunciation of them, constant worry, all the time. I'm sure it's named that for a reason. Approved in 2021, lecanemab removes the amyloid plaques that build up in the brain of people with Alzheimer's. The drug doesn't stop the disease, but in a clinical trial, lecanemab slowed cognitive decline by about 30% over 18 months compared with the placebo. So that's pretty great. Actually, honestly, I might go over the CRISPR thing, just for more details. A gene therapy for muscular dystrophy. In June, the FDA approved the first gene therapy for children with, I think is it Duchenne or Duquesne? I don't know. My apologies for my pronunciation and stuff. Muscular dystrophy. Due to a faulty gene, people with this muscle-wasting disease don't make the protein dystrophin, which helps keep muscle cells intact. The therapy helps the body produce a version of the missing protein. So you're guarding against RSV. Several ways to protect against respiratory syncytial virus arrived this year. In May, the FDA approved the first RSV vaccine, called Arexvy, in the United States for adults aged 60 and older. And then in August, a vaccine for pregnant people called Bristovo, a monoclonal antibody, a lab-made antibody that mimics immune system proteins, won approval in July to protect children 2 and younger from the virus, which sends as many as 80,000 young children to U.S. hospitals each year. What was I gonna say? Oh yeah, this reminds me of the, learned about the latest COVID vaccine. And how apparently now it's gonna cost money, and I'm like, oh man. Like, that kind of blows. But, you know. Unsure how many people are taking the boosters and whatnot every single time now. But in October, limited supplies of therapy led the U.S. Centers for Disease Control and Prevention to recommend reserving it for babies at highest risk for complications from RSV. Ooh, pill for postpartum depression. I maybe heard about this as well. Until August, the only medication in the United States specifically targeting postpartum depression required a 60-hour intravenous infusion in a hospital. With FDA approval of zuranolone, brand name Zurzuvae, those afflicted with postpartum depression could take an oral medication at home, experience improvement in as little as 3 days. Which, man, postpartum depression stuff is so... it's so, like, wild with how little we know about, like, what causes it, why it happens. It's kind of scary almost. Violence it? I don't... If that was a recent thing, I don't think so. Let's see. Birth control, no prescription required, which... Wild. In July, the FDA ruled that the oral contraceptive Norgestrel, first approved in 1973, be available without a prescription. It's the first OTC daily birth control pill in the United States. Some public health experts argue that reducing barriers to contraception is especially important to reproductive autonomy now that state bans have limited access to abortion. Ugh, yeah, this is annoying. If you don't know, like, the US, earlier this year, a bunch of assholes were just like, they were like, hey, actually, we think you shouldn't be allowed to have abortions. Fuck you, women. And it's like, wow, that is so fucking cool of you. And wild that they could do that, but so cool. So you can get a birth control without a prescription. Hello, Bob. Let's see. We learned that reindeer can see UV because specifically they can see lichen that absorbs UV in the wintry snow. Learned that apes can remember their friends after many decades. What was the first thing? Forget the other thing. And also that, for trans women, it may be better to just go through vocal therapy rather than go through HRT for changing your voice. And now we're just going over some of the general medical advances that have happened in 2023. Let's see, so the chikungunya virus can cause fever and severe joint pain, be fatal in newborns. In November, the FDA approved the first vaccine against the virus, which is transmitted by mosquitoes. Man, I feel like some of these things we did talk about, because I remember talking about something being transmitted by mosquitoes. The virus is most prevalent in tropical regions. The FDA warns it's spreading in new parts of the globe. Narcan over the counter. Nasal spray Narcan, aka Nalozone, can reverse the effects of an opioid overdose within minutes. So this was pretty interesting. In March, the FDA ruled this life-saving therapy can be sold over the counter. Officials hope that easier access to Narcan can help fight the opioid epidemic, which claimed the lives of nearly 645,000 people from 1999 to 2021 due to overdoses. Oh yeah. It was pretty interesting because it was talking about how it was good because it's a step towards, at least in America, to be like, hey, insurance companies, please, vocal therapy is very, you know, is very viable for trans people. Please allow it to be covered by insurance. You assholes. But at least it seems to be less, in general, less expensive than just doing HRT for strictly just voice. All right, so yeah, pretty good year for medical advances. Let me jump into this CRISPR therapy for sickle cell real quick, or I won't, because I tried to get around this just by doing like a 10-minute mail or something, but they straight up want you to sign up, so they're like, give us your email, get a password, blah blah, and I'm like, I don't want to set up an account, I just want to read whatever. So you know what, it's fine, we'll pass the CRISPR therapy. We'll probably talk about it later when we have a bit more about the story as it develops. Yeah, hope everything goes well with that. Good luck. This one we will probably wait on because this will get pretty in-depth, I think. So we'll jump to this. How brain transplants are treating depression. This is kind of interesting and short, but it's an experimental surgery that sends electricity into the brain that may offer relief from mental disorders. You know, technically there are do-it-yourself CRISPR kits out there, but it seems more like a scientific experiment kind of kit more than anything. And I also worry about just putting gene editing tools into the hands of the public in general, because let's be honest, the public's not gonna know what to do with that, and if they start just injecting stuff into them to change their genes, it's gonna be not good. Yeah, it's pretty. Here, I wonder if I can find it. Let's see. CRISPR do-it-yourself kit. I know it's like, oh yeah, definitely don't get this thing, and then here I am showing it, but is this the company? Is it the Odin? Maybe, but yeah, it's basically just like, oh, you can, you know, you can take these bacteria, you can, and then you can do a very basic, like, science class experiment on changing some, like, bacterial genes or whatever. And so it's kind of interesting in a, like, hey, if you just want to try that, that's cool. But I'm pretty sure with the company that made this, they were like, yeah, our goal is, like, for it to be available for everyone. And I'm like, you don't know what you're talking about. Okay, I think this is them. Biohack the planet. Well, it looks like the Odin is maybe the official site. I'm curious, 85 to 179, what's the difference? It's a very... Let's see. Uses kit to learn okay, so this is fine. Learning molecular biology and genetic engineering, it's fine. Oh wait, they say instead recommend that you purchase their Learn Bioengineering class, which includes this kit as part of it. Ah, so they are just pushing their own products to be like... Sorry, I realize this is probably really tiny text to read. But they are just pushing their own, like, oh, buy our stuff, buy our videos. Woof. Yeah, you don't need the video. You can probably just follow the instructions. Using E. coli, which is a very basic, like, bacterium to use for those kind of experiments. Ooh, they have the protocol here. Nice. And you can see the plasmid maps of the... Let's see. Okay. Well. Oh, wait. Yeah, so here's the sequence of it. Do gene editing with no training? There you go. Anyways, yeah, this is like a do-it-yourself. It's more of a lab experiment. I say lab. It's more like a classroom experiment rather than a actual, like, you know, because they give you all the materials. There's no way for you to... You would have to order some custom things if you wanted to do CRISPR and change other, you know, DNA sequences. So how CRISPR works is it uses RNA to actually... well, there's a few aspects. So it uses RNA to be able to recognize a sequence that it wants to change. So you would basically have to change that RNA sequence, and probably do a few other things depending on what you want to target. I'm just giving general instructions here on how everyone here can do gene editing. But yeah, this is basically like, oh, I think with what they use, the end product is your bacteria that did get the gene edit will look blue, and the bacteria that didn't get the gene editing will not look blue. And that's kind of the basis of it. Yeah. I don't like their future aspects of like, we want to let everyone have this sort of thing. Yeah, they sort of work in it. Well, they work in a way that they use RNA to target a sequence, but with the protein, the enzyme that comes with CRISPR-Cas9, that will also additionally, depending on the type of enzyme you have, can insert DNA into it or delete DNA, or can replace a sequence. It's entirely dependent and entirely dependent on what you want to do. That's okay. I can explain all the gene basis backing. But yeah, the thing is just, it's, so once you have CRISPR, like it will, you know, not work past a certain point, and that's one thing of, you can't just have it constantly working. But unfortunately, like, it's pretty, what's the word I'm looking for? It's very broad, and it will go after every sequence it finds that's like this. So it's like, oh, like, we wanted to after this specific sequence, but oops. Turns out this specific sequence is also in this gene here that is also editing, and that's, you know, it's like, that does something else important in your body. So it takes a lot of research to kind of okay this stuff. So that's why it's wild that the CRISPR-Cas9 therapy has started. I guess it depends on what you need to breed the animals for. Some gene things are easier to work with than others. If it's Mendelian genetics, that's much more simple and something more in-depth. Honestly, I wish I could say, do Space Station 13 become a geneticist? But it takes a bit more than just clicking on a base to change it. But I do like the aspect that they use to go through that. Anyways, where was I? Oh yeah. There are certain cells that can get passed on. Or like, say it's, I was about to say mitochondria. Well, yeah. No. You do get, say, like, mitochondria from mom versus dad. And so, like, if someone's in your... But it's not nuclear genetics. which isn't that annoying, doing sequencing, and then you find out, like, oh man, I'm just looking at the mitochondrial DNA rather than the nucleus DNA. But there's also the thing of whether it is in, say, like a sperm egg cell versus just a regular cell, and with how those cells reproduce is the wrong word, but with how those cells split, it can be different with how those genes will recombine and everything. So, sort of, but not as worrisome with CRISPR and stuff. We kind of are Frankenstein. Again, whenever anyone says that you require bacteria to live, like, they're not kidding. We are so ingrained and evolved with bacteria that we cannot be without them and without a lot of what they do for us. It's why I'm kind of interested in microbiome stuff a lot as well, because I think that's a very good, relatively recent field that's like, oh yeah, it's like this stuff does actually affect a lot of how you live. Oh, we're Dr. Frankenstein, not the monster. No, we're monsters as well, but absolutely, we are also making monsters. We are. Which came first, the chicken or the egg? You know. Anyways, this one comes with a bit more of a story. So let's see. On a hot sunny Sunday afternoon in Manhattan, time froze for John Nelson. He stood on the sidewalk and said goodbye to his 3 kids, whose grandfather had come into the city from Long Island to pick them up. Like any parent, John is deeply attuned to his children's quirks. His oldest, sometimes quiet, but bitingly funny. His middle kid, rates Dad a 10 out of 10 on the embarrassment scale and doesn't need a hug. Very good. His 10-year-old son, the baby of the family, is the emotional one. My youngest son would climb back up into my wife's room if he could, John says. He's that kid. Yeah, poop transplants, that's true too. It's wild the amount of things that we've created to change stuff. Industrial pigs. I admittedly am not very familiar with different kind of pigs, but are they? Is it kind of like the? I don't know. When I think of something like industrial pig, I probably think like what the hell was it? The game that's all about you being in that like fungal forest or dark woods. I'd have to look it up again. I don't remember. But it reminds me of the pig in that game where it's just this giant thing that's used for meat or for spitting out pigs for meat. Anyways, an unexpected parade had snarled traffic, so John parked illegally along a yellow curb on 36th Street, near where his father-in-law was waiting. It was time to go. His youngest gave the last hug. He looked up, scared and sad. John says and asks, Dad, am I gonna see you again? That question stopped the clock. I was like, oh man, John says. It was one of those moments where I was living it through his eyes. And I got scared for the first time. This music is a little too cheery for this story, but it'll have a good turn, I swear. I do know boars are quite a problem as well. Until that goodbye, John hadn't wanted to live. For years he had a constant yearning to die. He talks about it like it was an addiction, as he fought deep, debilitating depression. But his son's question pierced through that heaviness and reached something inside him. It was the first time I really thought about it. I was like, I kind of hope I don't die. I hadn't had that feeling in so long. That hug happened around 5 p.m. on August 21st, 2022. 12 hours later, John was wheeled into a surgical suite. There, at Mount Sinai's hospital, just southwest of Central Park, surgery team members screwed John's head into a frame to hold it still. Then they numbed him and drilled 2 small holes through the top of his skull, one each side. Through each hole, a surgeon plunged a long, thin wire dotted at the end with electrodes deep into his brain. Which I'm curious about how with brain works. How careful you have to be with that. I mean, obviously, I don't think they just, like, jab it in. But if you have to, like, it'll get somewhere. Trust me, it'll get somewhere. They're just taking us through the... They're just taking us through the story of John. So let's see. Electrodes deep into his brain, the wiring thread under his skin snaked around the outside of John's skull and sank down behind his ear. From there, a wire wrapped around to the front, meaning a battery-powered control box that surgeons implanted in his chest just below his collarbone. During the surgery and the days after, doctors sent small pulses of electricity into John's brain. In ways that are so unclear, this electrical tinkering changes the messages that move between different brain regions. The doctors and researchers had what seems like a bold goal. They wanted these pulses to pull John out of the darkness of depression. John's one of dozens of people in the United States currently in clinical trials that aim to heal mental disorders with brain implants. The technique is called deep brain stimulation, and it's built on the scientific premise that electrical stimulation can reset brains that are in the grip of powerful and devastating psychiatric disorders, such as depression, obsessive-compulsive disorder, and post-traumatic stress disorder. So essentially what this is, when I first glanced at this, I didn't know they kept it in their heads for like days after. I thought it was just during the surgery. So it makes me a bit wary of it, but talking about how using electrical stimulations of your brain to, I guess I don't even know if change the chemistry is the right phrase, but to sort of manipulate it a little so that you don't have some of those more like not as well understood and debilitating disorders. Every time we say pig welfare, it really just makes me think of like a pig economy and pig money. But yeah, I can definitely in my head see all the like pig farms and such in places where it's like, yeah, they can't move. The food industry is quite crazy. Alright, so let's see, this is deep brain stimulation. I first heard about deep brain stimulation, or DBS, more than a decade ago in 2010. As a science reporter, I was sitting in a cavernous conference room packed with neuroscientists in San Diego. We were listening to a presentation by Helen Mayberg, a neurologist and neuroscientist who was then at Emory University in Atlanta. As she spoke, Mayberg walked the audience through the scientific rationale for the idea that electrodes pushed down into the brain could alleviate severe depression. Toward the end of her presentation, Mayberg showed a video of a woman who had severe depression. A day before the video was taken, doctors had implanted electrodes into the woman's brain. Researchers in the video turned on the stimulation, and within a minute, just like that, the woman wanted to smile and laugh. Transformation floored me, and judging by the audience reaction, a lot of other people too. In November of 2022, I caught up with Mayberg, again at a neuroscience meeting, again in San Diego. Talked about what happened the years since that presentation and where the research was going. It hasn't been an easy road, says Mayberg, who now directs the Nash Family Center for Advanced Circuit Therapeutics at the Icahn School of Medicine at Mount Sinai. Science of DBS is saying lots of twists and turns. God. Yeah, it's probably extremely unhealthy for them as well. I can see them trying to phrase it, they'll be like, oh, the money enclosures are really good enrichment centers for them or something. That's probably not great. So let's see. So the journeys of people who participated in this research, to hear one of those stories, Mayberg put me in touch with John. For the series, I talked with him and his wife, as well as 3 other people who had lived with severe depression and are now being treated with deep brain stimulation. These people's paths have been incredibly tough, and while they still face challenges, they've been crystal clear about what DBS has done for them. This experimental brain surgery is giving them back their lives. This is kind of what it looks like. They have the implants, and then, you know, it comes out of their skull, and then here's the wire leading around it. And again, for every kind of therapeutic, medical therapeutics, I always wonder, like, what is the long-term, what's the long-term look at this? Like, you know, does this person constantly have to come in to get this looked at or done? Or, you know, can they do it themselves? Hooked up to a taser? Yeah, and that too. It's like, what if something, like, connects to it, and, like, what if these people get shocked or something? Like, how can that affect it? And so, you know, I guess we'll... right, yeah. We'll just pump them full of more electricity. So I guess we'll see how that goes. Since it's been a decade since they came up with this, and are still going. Yeah, me too. I'm not a big fan of, like, any invasive thing that doesn't need to be done. And yeah, also you would have to, I mean, I guess we kind of have ways to do it, but quantifying, quote unquote, how bad someone's depression is, to where it's like, oh, do they really need it? Ugh, I'm losing my voice. And also, how, yeah, would it be like something where over time it's less effective, or? Infection would definitely be something as well. And I'm curious if there are people that they did do this on and it didn't do anything. You know, to when then it's just like, well, cool, now I just have these electrodes in my head and it's not doing anything for me, so I have to get them removed. I think the rest is just about John's story. Okay, so yeah, that's more or less it for this one. I will say, there's a billboard, it's around where I live, that talks about ketamine for depression, but in my head, I always just think of, like, memes of ketamine and, like, Mr. Krabs and stuff, and the billboard just straight up says, like, it's like, have depression? Try ketamine. And so in my mind, they're being like, have depression? Why don't you just try overdosing? But that is a, like, legitimate, you know, sort of way to go about it. But I just very much love the billboard being like, go on, take some ketamine. And also with this, again, with everything that relies on technology, I'm curious about, like, what is the, like, will the company still be around in, say, like, a decade, or, like, you know, if it's one company that does it, I would be like, I don't know about that. That sounds like a bad idea. Because if that company flops in, say, like, 2 years, then it's like, well, shit. You know, you're pretty much left up shit's creek, kinda. Yeah. Go on. Just, trust this. Once you have this in your head, you'll love it. There was a... Oh, what the hell was it? American company called, like, Smile something. And basically it was like a... I don't even think it was like an orthopedics thing, but it was for teeth straightening. And the way they went about it was pretty bad, actually. But its company just flopped overnight. And all of a sudden, it was like Yeah, they were out of business. And what they do is like they would kind of just make retainers without actually doing any teeth straightening with traditional braces first, which was not the right way to go about it because a lot of things have shown like, oh, that actually fucks up your teeth more. Yeah, and it was just really bad because like I heard one story where this girl heard from her friend that the company went under, and she was like, what? No, I just saw them like the other day. She's like, I have an appointment with them, like next week or whatever. So the next day she calls, and the line's just like, yeah, this company's no longer around or like in service or whatever. And I think she drove up there, and there was just no one in the building. It was completely abandoned. And so it's like, it's like, holy shit, just overnight, they, I guess said they went bankrupt or whatever, and just everyone that worked for that company is without a job, and all the patients that are for that company no longer have care because that company doesn't exist. And so I'm like, God, man, that sucks so much. And like, how does this happen? How do companies they're just gone in a night? It's like, it doesn't make any fucking sense. Yeah. America's really, I'm not gonna lie, things have gotten so bad at this point. I am straight up just like talking with my wife. I was like, so I'm like, what country would you want to move to? Because I'll be honest with you, I don't think it's getting any better. But yeah, any brand new like technological advance for curing something or helping with something, I would be very cautious of it, because unless another company is doing it as well, if a company is just like, oh, we're the one and only people that do this, it's like, again, I bring up the story of also the company that did the eye implants, and they went under, and now all those people just have essentially, like, once the battery life in their eye implant dies out, then they're just blind in that eye, and they have a hunk of metal sitting in their skull. So it's very scary to trust any of that kind of stuff. Anyways, here's that last article I was talking about. Talking about how today's gene therapies rely on viruses, and that's a problem. And talking about CRISPR as well. Let's see, this is Will showing Dr. Jerry in Columbus, Ohio, received experimental gene therapy for, this is the muscular dystrophy. That's right. We all have to strive to be true Sigmas. We just fix our body. We take our teeth, we jam them the right orientation. Do everything yourself. Right. Yeah. God. The phrase from your, pull yourself up. Pull up your own bootstraps or whatever. So dumb. So this is kind of a relatively good point. I guess relying on viruses alone. But it's also one of those things of we hijack a lot of, kind of like you said earlier, we are just basically Dr. Frankenstein. We're hijacking like natural biological things and mechanisms to treat things, which I think is very good. But we'll see what this gets into. So let's see. Will Ungare isn't a typical fourth grader. A 10-year-old from Midlothian, Virginia, plays tag with his friends and swims in the ocean. I think his peers would describe him as someone who's kind, sweet, and funny, and super smart, says his mother, Sheila. He won a countywide citizenship award as named Classroom Student of the Year. But he's not a really fast runner, his peers might say. He doesn't really run. Will was born with, you know what, I actually have to look up how to pronounce this if I'm going to read an article about it. Okay, Duchenne. Duchenne. Okay, that makes sense. Duchenne muscular dystrophy, a genetic disease that causes muscles throughout the body to break down over time. That includes not only skeletal muscles, but also the heart and diaphragm, which controls breathing. You know what? Actually, I want to go into a slight tangent with this. Like I said, with science, you're always seeing new words that you don't know what they are. And so pronunciation them can be weird. But, alright, have a good dinner. But my coworker told me a story once of when she was doing a, she was giving a presentation, or just a like poster, and it was about HIV. And a person came up to her poster and was like looking at it, was like, oh, you know, like very interesting and everything. But the person was like, person was asking her, he's like, can you tell me, like, what is HIV? And she was like, huh? And he was like, HIV, what is that? And she was like, HIV, like, you know, she's just like, what is he talking about? And she realized, she's like, oh, he's talking about HIV. And this man was, this man was pronouncing it HIV. And, you know, like, God bless this dude. I don't know anything about him. I don't know anything about his background or anything. But this was like in the 2000 teens, you know? It was like, I feel like everyone's heard of HIV by that point. And, you know, maybe it was just a brain fart or something. But yeah, it is just funny to hear someone pronounce something like completely differently when you're like that. You're like, that's not what that is. So let's see. So Will's got Duchenne muscular dystrophy. That includes not only skeletal muscles, but also heart and diaphragm, which controls breathing. Eventually, these important muscles stop working properly, leading to death. The disease is caused by mutations in a gene responsible for dystrophin, a protein that acts as a shock absorber to prevent damage as muscles contract. It affects an estimated 4.8 out of 100,000 people worldwide. That's quite a few. Or, I mean, quite small. Mainly boys and young men. About 10,000 people in the United States have Duchenne muscular dystrophy. Tortilla, yeah, I remember. I think it was the word leotard, and I heard someone pronounce it like lettered or something. But you know, that's just the English language. Well, English language plus whatever other language, baby. Things are always pronounced differently or spelled differently, and it's annoying to say the least. Yeah, I mean, to be fair, there are some fun things to say, like tortilla. And I was gonna say tomato and potato, but I know that some places do kind of pronounce it that way. Yes, see, that's what I'm saying, is like, I'm trying to remember that, and there's other words that English language taken and just been like, no, it's pronounced this way. And it's like, no, that's not how it's pronounced, but that's fine. So let's see. Will celebrated his birthday last year at a laser tag park, as Mars says, but other kids his age with Duchenne's don't ride the bus. Okay, I'm sorry. I'm going to this. Okay. I just wanted to get to the actual stuff that we're getting on. So let's see. Difference is that Will received an experimental gene therapy when he was 5 years old. Just before Christmas in 2018, doctors at Nationwide Children's Hospital in Columbus, Ohio, gave Will an infusion of viruses. Those viruses delivered instructions to his muscles for making a short form of the dystrophin protein. And I would have to, I actually don't know about Duchenne muscle, or yeah, I don't know about Duchenne, so I would have to look up the exact cause and mechanism with how the dystrophin protein works and everything, but let's see. So, scientists at Sarepta Therapeutics in Cambridge, Massachusetts, the company that makes the gene therapy, developed this version called microdystrophin to act as a replacement, hopefully protecting muscles from harm. Though the therapy did not show statistically meaningful improvements compared with the placebo in one randomized control trial, the results of an ongoing clinical trial to determine efficacy aren't yet published, Will and the 83 other boys in Sarepta's clinical trials now make the microdystrophin protein. Based in part on the evidence, the US FDA approved the therapy earlier this year for use in 4 and 5-year-olds. And the first child to get the therapy after approval was infused on August 2nd. Oh, did we see that in the other one? For Sheila, there's no question that the gene therapy is working for Will. He now does everyday things he couldn't before, such as climb stairs easily and brush his teeth and get dressed on his own. He can ride a bike and swim up to 500 meters at swim team practice. A few months after infusion, Sheila overheard Will talk to his younger brother Adam. I was just outside the door and he said, "Adam, remember when my legs used to hurt all the time? They don't hurt anymore," she recalls. That was his experience of life with inflamed muscles in his legs that were being damaged constantly. And then, for that to subside is just an immeasurable impact on his life. The FDA has approved 7 other gene therapies for rare genetic diseases, all since 2017. Each puts a healthy copy of a gene in the cells to compensate for a missing or mutated one. Some potential treatments for rare diseases that use gene editing, a type of gene therapy that makes targeted changes at the DNA level, may soon win approval too. Which hopefully those all, are good. And again, it's like, this kind of stuff I feel, it's a little scary, but I feel a little bit safer with, because it's like, oh, it's not one company trying to use CRISPR. It's, it's relatively free, like, a bunch of companies can use it. So it's not like the support for it's just going to disappear overnight. So let's see, around the world, more than 2,000 gene therapies are in development, according to the American Society of Gene and Cell Therapy. That figure includes cells that have been genetically engineered to fight diseases, such as immune cells, called CAR T cells, programmed to kill cancer or keep lupus from attacking the body. But unlike these therapies for cancer and autoimmune diseases, which could treat potentially millions of people, making them financially attractive to drug companies, each gene therapy for a rare disease may help thousands of patients or fewer. Since gene therapy was first proposed to treat such genetic diseases in the 1970s, it has had thrilling highs, including the first successful gene therapy in 1990, in a 4-year-old born with severe combined immunodeficiency, or SCID, and deeply troubling lows. Clinical trial participants have ended up with cancer and other serious health complications and have even died. Yeah, so that's the kind of scary thing about any kind of gene therapy. The biggest problem appears to be viruses used to carry replacement genes where they need to go. Viruses are the obvious choice for delivery. They can carry the replacement gene in their own DNA or RNA and have built-in mechanisms for gaining the cells. But viruses can't always get the genes to the right cells, can slip the cargo into the wrong spot in the DNA, and can trigger the immune system's self-deadly inflammation. Yeah, so that's where the article is kind of getting down to is, like, hey, viruses are great. That, like, it's awesome that we can use that, but it's not exactly infallible all the time. So let's see. Challenge setbacks, including the death of a teenager named Jesse Gelsinger in 1999, nearly derailed gene therapy, but researchers, companies, and patient advocacy groups persevered. Today, researchers are finding new ways to tackle their delivery dilemmas. Some are developing better viruses or non-viral fairies, while others are using new tools to repair or replace damaged genes in place. One technique tested so far only in mice relies on technology similar to what has been used in COVID-19 vaccines. Okay, for a second I was like, is that the end? Some researchers say the outlook has been never been brighter for gene therapy for a wide variety of inherited diseases. Others are frustrated by the slow progress. So, what's the current state of gene therapy? When scientists discovered the gene that is mutating cystic fibrosis in 1989, gene therapy was just about to be demonstrated in clinical trials in people. We're all saying, there's going to be gene therapy next year, says Gary Cutting, a geneticist at Johns Hopkins who studied the disease. But that prediction didn't pan out. There have been at least 36 gene therapy trials involving more than 600 people with cystic fibrosis. None with lasting success, researchers reported in 2022. Which that's disappointing. Let's see, what's the problem? The problem has always been delivery, Cutting says. How do you get it into the right place? Yeah, so with a lot of pharmaceutical therapeutics, trying to targeted therapeutics is a very interesting and complicated process for. Yeah, it's like, oh, I need this to go to, say, the bones, or I need this to go into, like, liver cells. But how do I get it from going to, like, your pancreas or something, you know? So that's a constant battle when trying to look at any kind of pharmaceutical therapeutic. So let's see, for cystic fibrosis, which affects more than 160,000 people worldwide, the right place is the lungs, where mutations in a gene called CFTR result in the buildup of sticky mucus that makes it hard to breathe. Numerous clinical trials have attempted to slip a healthy copy of the gene to stem cells to replenish the airway lining, but it's not easy for viruses to get through the sticky mucus, past patrolling immune cells, through layers of unrelated cells and into the stem cells. It's a harsh environment. It's a tough problem, Cutting says. It's a good thing this is the last one because my voice is going. Editing cells outside the body, or ex vivo, has worked for rare diseases that affect the blood or immune system. It comes with limitations, and scientists haven't worked out ways to extract stem cells from tissues other than blood and bone marrow and replace them later. It also comes with its own dangers. It typically requires chemotherapy to kill existing bone marrow so the modified cells can take hold and replicate. And the viruses ferrying the replacement genes into the cells in the lab can still be problematic. Okay, so this is the ex vivo versus in vivo therapy. So I'm assuming, without reading this, I'm assuming this is taking, like, stem cells and taking the DNA into the, from the viruses, put in there, and this one you just taking the virus, and then replicating that, and then putting it in them. Let's see, many early gene therapies remove stem cells from a patient's body, modify them with the help of viruses, and then return the modified cells. The ex vivo approach often requires chemotherapy and only works for some diseases. In vivo therapies modify cells in the body, but getting therapies to the right cells can be a problem. Early gene therapies use retroviruses, which often insert their DNA cargo near active genes. Some children who got gene therapy in 1999 and 2000 for inherited diseases that disabled the immune system developed leukemia when the inserted gene ramped up activity nearby causing genes. That's why everything's gotta go through a lot of animal trials and a lot of clinical trials before we can be like, yes, like this is definitely, safe enough for whatever we need it for. Let's see, most gene therapies today instead rely on viruses engineered to deliver their cargo to safer locations and to cause less of an immune response. Still, the track record is far from spotless. September 2022, for example, the gene therapy company Bluebird Bio, based in Somerville, Massachusetts, received FDA approval for an ex vivo lentivirus-delivered gene therapy for children with a rare fatal neurodegenerative disease known as cerebral adrenoleukodystrophy. So lentivirus is like kind of the go-to virus for a lot of delivery systems. About 4,000 to about 150,000 babies born will have adrenoleukodystrophy, and 35% to 40% of boys with the disease develop the severe form, which typically leads to death within 5 to 10 years if treatment doesn't work. The approval came despite 3 cases. Oops, I accidentally hit the back button, and now it won't let me read anymore. Well, I guess that kind of cuts that article short. But yeah, the takeaway is, like, hey, we got this technology of, virus delivery and to do gene therapy and such. And that's great and all, but it do be coming with possible side effects that we also have to tackle along with it, which, you know, I would say with all medical stuff is always the case. You know, we can't live forever, and we're just constantly fighting. You know, we take care of this problem, and another problem comes up later, and then it's just like moving on to, okay, well, how do we take care of that problem? It's always just about trying to extend or at least make the quality of life better for patients with diseases. But yeah, that's more or less all I had for today. I don't think there was... Yeah, I think that was all the articles I wanted to go through. So, yeah. That'll be the last stream of the year. Well, I don't know, maybe next week I might pop in for a stream or two. But, that's the last science stream for the year. Unless... But we'll see. Hope everyone... let's see, I'll be gone. If there is a chance I do a stream next week, it will only be Wednesday or Thursday. And more or less I'll be gone until the New Year's. And probably streaming sometime the first week of January. But you know, I hope everyone has a good rest of their day or night. Hope everyone has a good last couple of weeks of 2023. And I will see you all next time. Goodbye.